Good afternoon, Rishikesh. Rishikesh, am I audible? Rishikesh?
Hello.
Yeah.
Yes, sir. Good afternoon, sir.
Okay, your voice
Am I
is.
audible?
Yeah, now you are. So I'll start the lecture now and I'll send the recording so if for others.
Yes, sir. Some will join as we go by.
Okay,
We can start now. Okay.
okay. The voice is not very clear, but I think you are asking me to wait for some time. Okay, let me start now.
Yes, sir.
Yeah. Okay. So up till now we have seen the block ciphers. Okay, the symmetric and asymmetric key cryptography. So we have seen a couple of algorithms, AES and DES for symmetric key cryptography, where only one key is used. And we have seen asymmetric key where two keys are used, public key and private key. We have seen RSA. So for the block ciphers, both of these are the block ciphers. Block cipher is like it is divided into number of modes of operation, which is there in your syllabus now. Uh, the modes of operations, that means how we can process that block. Okay, so in DES there was a feastal function where there are number of rounds and all these things. So that is one type of operation of mode. Okay, so what are the different types of modes of operation uh, in block cipher that we are going to study today? So as you know, the block cipher processes the data block of a fixed size. So we divide the data into number of blocks of same size, and then we process each block at a time. Okay, so how do you process those blocks? That is one thing. That is the first question. Okay, and first block is always usually it's a larger size block because it contains more information like controlling of the data, and then next blocks are quite of the same size. And you can study this you know, in detail, let me go back to the these four operations. Okay, the first one is electronic code book, that is called as ECB mode. The second mode is cipher blockchaining. Okay, so there is a chain operation which happens in the cryptography, and feedback and counter. So we'll see them one by one. So let us study what is electronic code book. Okay, so if you look at the example here, let's say this is one block of the plain text, original message. Okay, so it goes into the what you can say, the encryption algorithm. Okay, and then it creates a encrypted text, that is ciphertext. Okay, it uses some key, right? And the same, this process happens for each block. Okay, so it is very simple thing. What you do is you create a cipher text using some encryption algorithm, using some key, k key. Okay, on plain text. Okay, and I represents the block number. Okay, so let us say we are coding this in a for loop, and I represents for from 0 to the last number, block number. Okay, and you process each block in the same way. Okay, so it's a very simple thing. Even at the decryption thing, you use the reverse process. You input the ciphertext into decryption method, and then to produce the plain text. Now the problem with this is the attackers will come to know what exactly is the operation on the encryption and decryption part. Okay, how? Let us consider that if a plain text is getting repeated quite a few times in the original message. Okay, let us say I'm writing the word, uh, let's say the word is defense. Okay, so if that defense word is continuously getting repeated in my original message, let's say there is a document which is a very uh, secure document. Okay, confidential document, and I need to decrypt, encrypt that document. But that document contains the word defense quite a few times. Okay, because it is a let's say document contains all the defense related contents. Now, what happens is if there is a plain text which contains defense word, okay, it will get into some ciphertext using the key. Okay, so if you are using the same algorithm, same key for all the blocks, and if that block is getting repeated multiple times, let's say defense word is getting repeated at multiple times, the decryption also will be repeated. Okay, so if what will happen is if you are getting a if the attacker is getting a ciphertext, then it will come to know that what kind of word we are using uh, for how many times and all these things. So it becomes very easy to do the crypt analysis. Okay, so there is a term which is called as symmetric crypt analysis and asymmetric crypt analysis. uh, so in your syllabus there is a concept of crypt analysis. What it does, it it is the actually I have already told you that crypt analysis means the method by which you find out what is the how this encryption is done. So that method is repeated by the attacker. Okay, so the crypt analysis becomes very easy for the ECB, electronic code book. Okay, so and why this is called as electronic code book? Because you're using the same key, you're using the same algorithm for all the blocks, and it becomes a code book. So this kind of plain text will be converted into this kind of ciphertext. Okay, so even if you repeat that text for multiple times, you will get the same output. Okay, same ciphertext. So that it becomes a code book. Okay, it's an electronic code book. which gets transferred, and then encryption decryption occurs. Okay, so this is a very simple mode of operation. Then comes the cipher blockchain. So the problem of ECB is solved over here. Okay, uh, what happens here is we are using the same key. Okay, at all the times. We are also using the same encryption algorithm at all the times for all the blocks. But there is one change we are doing in the at the time of plain text. Uh, we are using initialization vector, that is IV. Now what happens is this is the random characterization that we are using. Okay, so we use the random function which generates this data. Okay, that data will be XORed with the plain text, and then the ciphertext is created. Now for the next round, okay, for the next block, what happens is the instead of initialization vector, the ciphertext itself becomes the initialization vector for the next block. Okay, so the next block will be XORed with the ciphertext. Okay, and then the new ciphertext will be created. Now consider that the defense word is there in this text box also and in this text box also. Why the ciphertext is different at both the times, even if the plain text is same? Just because you are XORing that plain text with the different data. Okay, here you are XORing with IV initialization vector. Here you are XORing with the different cipher. So this happens in a chain operation. So cipher, which is considered as a block, will be feed into the next round of next block for XOR operation. And this is why, and this happens in a chain mode. So that's why the name of the mode is cipher block chaining mode. Okay, so this is more secure when we consider the encryption and decryption. So at the time of decryption, whatever the ciphertext you are putting uh, into the decryption format, uh, to produce the plain text, you use the same initialization vector as an XOR operation after the decryption. Okay, so you do the exact reverse thing in the decryption, but the chaining operation will be the same. Okay, so the ciphertext is going to be XORed with the plain text, just like this. Okay, so this is how the cipher block chaining will take place. These are the advantages and disadvantages. What are the advantages? It is more secure than the ECB mode. And the hash value, that is, if you try to calculate the hash value of the all the blocks or this last ciphertext block, it helps to identify the message from the original or modified. So what happens is whenever you are calculating the hash values of each block, okay, it and someone is trying to tamper this ciphertext, you'll come to know easily whether it is tampered or not. Okay, just because of all these chaining mode. Okay, now what are the disadvantage? The problem here is the parallel operation cannot be performed. If you have a look at the ECB mode, all the blocks can go into the encryption parallel, so this is faster. But in CFB, what happens is you cannot perform this task unless this task is finished, because it takes the input from the first task. So parallel operation is not possible. So it becomes a bit slower than ECB, but that becomes a disadvantage. Okay. And suppose if there is any data or any block missing, if you consider any block get dropped, get lost, or something like that, then the complete operation goes down. Okay, because it is in the chaining part, the further blocks will be hampered, which are getting encrypted. So these are what happens in cipher block chaining or CBC mode. To reduce the problems in cipher block chaining mode, there is another mode which is called as cipher feedback mode. Okay, what happens is in the cipher feedback mode, you don't encrypt the actual plain text. Okay, you encrypt the initialization vector. So what you do is you do the encryption on IV itself, initialization vector, which is a randomizedly generated this thing. Okay, so what happens is you when you apply the encryption algorithm on IV and key, okay, the key will be used for encrypting the IV. Okay, then what you do is the plain text block will be XORed with some blocks of this encrypted text. Okay, some data. So if you have, let's say, 5 bits of block in the from the plain text, what you do is you select the 5 bits from the encrypted text and then XOR it with the plain text. Okay, and whatever the ciphertext you create, those ciphertext will be used for the input for the next round. Okay, so those 5 bits will be shifted over here. And what happens is this IV is bit longer than the plain text. Okay, so whatever you have discarded here, okay, that you can use it here as a B minus S bit. So let us consider IV initialization vector is of B bits. Let's say it is of 10 bits. Okay, so when it gets encrypted, it has 10 bits here. From that 10 bits, 5 bits are XORed with the plain text and 5 bits are discarded. Those 5 bits you can use it here. Okay, along with the ciphertext. Okay, so every time what you are doing, you are not actually encrypting the plain text. What you are encrypting, you are just encrypting the key itself. Okay, so the key is getting encrypted along with the initialization vector. Okay, so and this process is repeated in each round until you get the last block. Okay, so this is how this cipher feedback mode will be executed, and this is the decryption part. It is the exact reverse thing to obtain the plain text. Okay, from C1. Okay, so you get C1 that has to be decrypted first, right? And then it is provided to the encrypted part to produce the plain text. Okay, so now here is the security problem is more solved in this CFB mode, but the problem here is it is suffered from the bit errors. If you are shifting because you are using a shift register shift operation, if you miss a single bit for shifting operation or somewhere else, then whole operation in the chain gets hampered. If there is a single bit error, then it doesn't work. Okay, so these are some of the problems of each mode. There are some advantages of each mode. So what you have to remember as a for the exam is how does these mode works, what are the details of these modes. Like for every block you have to provide the same key. This can work in parallel mode. This is faster than other modes and all these things. So once you understand that particular mode, you'll be able to answer those similar objective question types of question in the exam. So the next mode is output feedback mode. It is more similar to cipher feedback mode. Okay, but it is free from the bit error. Okay, so if there is any problem with the one bit, it doesn't hamper the next bit. Okay, how does this done is instead of using initialization vector, we are using nonce here. What is nonce? Nonce is a mathematical concept which is defined as the number which is used only once. Okay, that is called as nonce. Now that nonce is actually we are inputting. So this operation is same of the cipher feedback mode, but what they are doing is they are keeping this encryption part completely separate from the plain text and the ciphertext. Okay, so if there is any error in this process, it will be completely different. Okay, so instead of using the output in a chain mode and the complete operation in a chain mode, what we are doing here is whatever the keys and nonce we are using here, that is completely separate, used as separate, and we are reducing the shift operation. So even if there is a bit error, it doesn't hamper or the bit error gets reduced because of the removal of shift operation. And then this operation will be kept separately. Okay, the plain text and the ciphertext. Okay, so if you XOR the plain text with the output of whatever the encryption you're doing here, it will create a ciphertext. Okay, uh, another advantage with this is the same process you can use for the decryption. Just you have to change the ciphertext input at the time of decryption. Okay, so the process is exactly same, only the P1 and C1 are changing their positions. Here C1 will be created from P1 and here P1 will be created from the C1. Okay, so this is what the difference between encryption and decryption. It is most similar looking like structure, but output feedback mode or OFB mode is more secure and easy from the cipher feedback mode, that is CF. Okay, then the counter method is used. Okay, now we want this process is as fast as possible. Okay, so how to make this very faster is to reduce this chaining process. Okay, so if you are using nonce here, what if you create nonce for each round, a separate nonce 1 which will not be used for anyone else, nonce 2 which will again not be used for anyone else. So instead of putting some random text as an output of this first round to the input of next round, instead of doing that, what we are doing is, what we need to do is we have to create a separate number for each one. Okay, so we provide the separate counter, which is a nonce 1 for this round, nonce 2 for this round, nonce 3 for next round, and so on. So this way we can do the things parallelly. We can achieve all the problems which are faced by all the earlier uh, operation modes, and we can do this process pretty faster. Okay, keeping the encryption completely different than the XOR operation of P1 and C1. Okay, so this is more faster, the counter method. Okay, uh, you don't require a padding. Encryption is can be done in parallel. That's why it becomes a faster. Okay, processing of plain text. These are some of the advantages that you can read out later. These are very simple things. Actually, these XTS AES mode, only AES mode you have in the syllabus. What is this XTS AES mode? What happens is you do the AES encryption first on the key. Okay, so instead of this simple encryption method, you are applying the AES encryption. When you apply some algorithm here, so here they tell you that you can use any encryption method because this is just a simple mode. We are not giving any algorithm name to these modes. Okay, what we are doing here in XTS AES mode, we are actually giving the AES as a name to the algorithm, encryption algorithm. Okay, so as soon as you use the AES, which is very secure encryption method, uh, the complete method is called as AES mode per block. Okay, XTS AES mode per block. Now, in this, what happens is this uh, I is a it is a counter which takes counter 0, counter 1, counter 2, and so on. It is XORed with another vector, initialization vector alpha, which is called as alpha. And you're just adding more uh, operations, okay, on the uh, one operation we are using. You are encrypting the key, and another operation you are encrypting the plain text to create a ciphertext. Okay, so if you notice here, we are encrypting only key here in the earlier modes, and we are just adding up the plain text into the encrypted form. But in XTS AES mode, to make this mode very secure, what we are doing is, after a couple of XOR operation, we are encrypting the complete plain text using another key. That is very important. We are using two different keys for this encryption, because encryption we are doing twice, so that's why two keys are used here. Okay, to create a ciphertext. So this is one example of encryption. And at the time of decryption, you just do this in a reverse order. Okay, encryption process will be the same for the key uh, whenever you are using key, but only the this is different at the time of decryption. So here do the encryption here, and you can do the decryption here. Okay, on the plain text. Okay, sorry, ciphertext, to produce the plain text. So this is the very secure method, or mode for that matter, which is called as XTS ES mode. Okay, and when you do that in a what you can say round method, then you can add more complexity, dividing the plain text into left part and right part, that we have already seen in the feastal cipher. Okay, so we have seen the feastal cipher where you are dividing the plain text into left part and right part, and you are exchanging the left and right part in the next round. So the same thing, same operations are done in the XTS AES mode. Okay, which becomes more secure when you use this kind of mode in the encryption. Okay, so so these are the modes of operations, and the cryptanalysis becomes very difficult. So whenever you are designing an encryption algorithm, or you are using any mode of operation, you should be clear that the crypt analysis, that is attacking methods, should become very tough for the attackers, so that this process will not be uh, compromised at any moment of time. So this one becomes more secure. Okay. Uh, Feastal network was a bit older than XTS AES mode, but is used in AES also in a different way. Okay. So these are the advantages and limitations of AES mode. Okay. It can do parallel operations. These are the efficiency or advantages. The random access to encrypted data blocks. You can access any block at any moment of time. Okay, uh, which has both nonce and counter. That means what? You are using I value also, and you are using nonce value also. So that's why it becomes more secure and more encrypted format. Okay, and you can store the data at any moment of time without worrying of whether it is getting compromised or not. Okay, so these are some of the modes that you have to study as a in unit 2. And this was the last topic of Unit 2. From next week, you'll be starting Unit 3. If you have any doubts, what we can do is you can text or WhatsApp me. We can discuss it in some extra session.
Okay, sir.
Yes, guys, any doubts? Rishi, Sonal.
No, sir.
So
Right now, sir,
when you,
but I will have it.
yeah, okay. So when you are studying these modes, the algorithms that we have studied, what I've done is I have kept Blowfish algorithm for self study for yourself. It's a very simple algorithm, but not used these days. So you just study this for the study purpose. Nowadays, most of the places AES is used and RSA is used. So that we have studied in detail. DS was very important to study because it was the basis of all the encryption algorithm, and which is some of the terminologies of DS are used in AES. So that's why we have to study DS in detail. So if you have any doubts, let me know. Okay. So I'll stop the recording now, and we'll send you the recording if you need it